When you need a pre-flight weather briefing, you'll probably take up residence in your favorite easy chair and let your fingers do the walking to your telephone for a call to flight service or to your computer keyboard to connect with duets. But what about once you're airborne? In flight, you can get weather through two-way communications or through broadcast recordings on selected VORs. Now, of course, you can always call the nearest flight service station for any weather request, but certain flight service stations across the country have been set up to provide en route Flight Advisory Service, or EFOS. If you find that confusing, just remember that EFOS spelled backwards is safe. EFOS uses the universal call sign FlightWatch. Now, the whole purpose of FlightWatch is to give you actual weather and thunderstorm information along your route of flight. You can also request your immediate destination weather and forecast, but you don't want to file flight plans or get a lot of extraneous information on this frequency. On FlightWatch, all aircraft below 18,000 feet use frequency 122.0. Those at higher altitudes have different discrete frequencies. The coverage is available in the 48 states between 6 a.m. and 10 p.m. as long as you're at least 5,000 feet AGL. To get the service, just call FlightWatch, tell them who you are and the VOR you're closest to, and the nearest FlightWatch will get back to you. And if you're curious about which flight service stations provide FlightWatch in your area, look at the airport facility directory for your area and take a look inside at the chart on the inside back cover. FlightWatch is a very good place to have your radio tuned anytime you aren't using it for something else. One reason for that is, in addition to the FlightWatch advisories, you can hear other pilots giving pilot reports, PIREPs, about the conditions where they're flying. They may be reporting the conditions for where you're headed also. And pilot reports from you, by the way, would be very much welcomed, especially if you encounter conditions different from your briefing or the forecast. Now, pilot reports are not kept as the exclusive possession of the FlightWatch crowd. In addition to FlightWatch, pilot reports are collected over flight service station and ATC frequencies and are distributed as one of the text reports you can get from flight service or over Duet. PIREPs are one of the best sources of information for actual flight conditions. You know a pilot report is from someone who knows what they're talking about because they're at the scene. So let's take a look at how pilot report information is recorded. PIREPs are divided into sections with slashes between the sections to identify the information that it's talking about. Now, first of all, you can tell that it's a pilot report because it starts with the letters UA. How does that come out to pilot report, you may ask? I don't know. Maybe it's because the FAA is thinking in terms of unreliable airmen or possibly upper air. Regardless, it's a pilot report. To be really helpful to you, it would be nice to know where the pilot was when she made the report. The abbreviation OV stands for over, and in this case, the pilot was over a route between OKC, Oklahoma City, and TUL, Tulsa. TM stands for time, and the time this particular pilot report was made was 1800 Zulu. FL stands for flight level or altitude, and you add 2 zeros. The altitude of the aircraft was 12,000 feet. Now, what type of aircraft was it? TP is type of aircraft, and in this case, it was a Cessna 182. Now, as far as the sky conditions are concerned, there's a section here that tells us what the pilot saw. SK for sky. The pilot reported bases of the clouds at 1,800 feet broken, add 2 zeros there, and the tops of the clouds at 5,500 feet. It's important to remember that these bases and tops, both of them, are given to you above sea level because that's how a pilot knows her altitude. Now let's see what else we can glean in the way of weather from this report. It looks like we're going to have another layer of clouds, an overcast layer with bases at 7,200 feet MSL, and the tops of that overcast layer are at 8,900 feet MSL. And after that, it says that it's clear. clear above. Now, TA stands for temperature. So the temperature, TA, at that altitude was -9 degrees, and that's degrees C. WV stands for wind direction and velocity, and here the wind direction is from 090 degrees true, and the wind speed is 21 knots. What else does that pilot have to tell us? Well, TB stands for turbulence, and she was reporting some moderate MDT turbulence, and the altitudes that the pilot got the turbulence between are 5,500 to 7,200 feet MSL. In the next section, IC stands for icing. The pilot encountered some light to moderate icing, and that was clear icing between the altitudes of 7,200 feet and 8,900 feet MSL. It's very valuable to know exactly what's happening between the weather reporting stations because it can tell you the actual in-flight conditions where you will be flying. Kind of takes the guesswork out of the weather.
Transcribed broadcast aviation weather 1500 Zulu observation unless otherwise stated. San Diego Lindbergh 900 scattered. Estimated ceiling 20,000 broken. Visibility 5.
This is another way to get
6,
weather information while you're en route. It's called a transcribed weather broadcast, or TWEB. What's a TWEB? It's simply a continuous tape recording of weather information, a weather briefing for specific routes of flight. It's broadcast over certain VOR stations and NDB stations. So how do you monitor the information on this continuous tape recording? Well, you can find out which VOR or NDB stations broadcast a TWEB by looking on the sectional chart legend. The legend says to look for a white T like this in a blue circle, and that means there's a transcribed weather broadcast. So when you take a look on the sectional chart itself, for instance, the identification box for Fillmore, in the upper right-hand corner of the identification box, you find that same white T in the blue circle, telling you that there's a TWEB. So to hear the broadcast, tune your nav receiver to the frequency, in this case 112.5, and select that radio on the audio panel. Here's yet another way to get critical weather information en route. Very critical information. The Hazardous In-Flight Weather Advisory Service, or HIWAS, is a continuous broadcast of SIGMETs, convective SIGMETs, and AirMets, plus some other stuff, over selected VOR stations. What you hear on HIWAS is stuff that is really dangerous to your airplane. Not just routine information about route forecasts and winds aloft, but information about developing thunderstorms, spreading areas of fog, and other information that is hazardous or potentially hazardous for your flight. How do you know which navigation stations will have HIWAS broadcast available? You look on the sectional chart legend. The chart legend tells you that a little square like this in the lower right corner of the communications box tells you that HIWAS can be heard there. So when you look on the chart itself, at the Daggett-Vortak identification box, for example, you see that you've got that symbol in the lower right corner. Again, just tune the frequency, 113.2 in this case, and listen to the audio on your nav receiver. You may be very glad that you did. It's a good way to avoid nasty surprises. And now you know how to stay connected to the weather gurus, even without a telephone or computer.